Okay, this part's pretty important. Here's how you can recognize a perfect square trinomial. The first and last terms are basically perfect squares, right? You can square root the first and last term. It's not always guaranteed if you can square root the first and last term that it is a perfect square, so you do have to check that middle term. Because remember, the middle term is 2 times as much as when you multiply them together. So we'll see that, and then I'll show you kind of like an example where if you could just square root each term, it's not necessarily a perfect square trinomial. So look here, x squared minus 8x plus 16. Can you square root x squared? Yeah, it's x. Can you square root 16? Yeah, that's 4 times 4. Now, if I multiply x times 4 together, it'd be 4x. If I multiply that by 2, is it 8x? Yeah, it is. So it's going to be whatever symbol is first goes between them. Because the last one's always plus. Because it's either a positive times positive is positive, or a negative times negative is positive. So you got to go with the first symbol on these. So it'd be x minus 4 squared. Now, let's say you don't remember that shortcut for this. You could look at your factors of 16 and say 1 and 16, 2 and 8, or 4 and 4. You could be like, oh, well, 4 and 4 add up to 8. So it'd be x minus 4 times x minus 4. And that's a pretty cool way to write it. But that can be written cooler. When you have something times itself, you write it as squared. Okay? Let's try a couple more. This one, very similar. Can you square root x squared? Yes. Can you square root 16? Yes. It'd be x and 4. If I multiply them together and multiply by 2, do I get 8x? Yes. The only difference here is our first symbol is plus. So it'd have to be x plus 4 squared. Or you can get it the long way. It's literally one more step, so don't worry about that. X plus 4 times x plus 4, and then you would just rewrite that as x plus 4 squared. You'll notice these are also very similar. They both have the 16n and the 64. The only difference is the first symbol, which would be the one that goes between them anyway. What's the square root of n squared? N. What's the square root of 64? 8. So this one would come out to n plus 8 squared. The other one, the only difference is that first symbol, so it would be n minus 8 squared. Now, I wanted to show you one example that can like throw you off a little bit if you're not careful. You might see something like x squared minus 13x plus 36. You might be like, oh, I can square root x squared. I see a minus, great. I can square root 36. But if I multiply x times 6, 6x, and I multiply by 2, do I get 13x? No, that would be 12x. So this one would be like a throw-off one. If you think of the factors of 36, we're actually looking for 4 and 9. Those are the set that adds up to 13. So this one would not be a perfect square trinomial. So just be careful. Just because you can square root the first and last doesn't automatically make it one of those. So this one would factor to x minus 4 times x minus 9. Just be careful. That's the only reason I wanted to show you that.